You're watching Statistics Made Simple, and I'm Savita Valsang. In this video, I'll find solutions to problems based on tests for single mean for small samples where n is less than 30. Problem 1. The length of 10 samples of cotton taken from a population has mean 48 centimeters and standard deviation 3 centimeters. Test whether the mean length of the population can be taken as 50 centimeters. This question, we see that the words mean and standard deviation are used, and we have only one population taken into consideration, and also the size of the sample is 10, which is less than 30. So the problem is considered as a problem under t-test for single mean. Since it is t-test for single mean, we should be able to obtain four values from the problem, that is n, x bar, mu naught, then either s square or s. Remember that under small sample test, the population variance sigma square or the population standard deviation sigma is unknown and it will never be given to us in the problem. So from the problem, under solution, write given n is equal to 10, x bar is equal to 48, s is equal to 3, mu naught is equal to 50. Since alpha is not mentioned in the problem, it is taken as 5%. Now the general format of the null hypothesis H naught under t-test for single mean is the population mean is mu naught, that is mu is equal to mu naught. Now here mu naught is 50, so H naught is written as the population mean is 50, that is mu equal to 50 versus H1 mu not equal to 50. The alternative is a two-tailed test because we don't have words mentioned like above, below, greater, less than. Next, write the test statistic. So under H naught, the test statistic is t equal to x bar minus mu naught divided by s by root n minus 1, which follows t n minus 1. Now substitute all the values in the test statistic formula. So which implies t is equal to 48 minus 50 divided by 3 by root of 10 minus 1, which is equal to minus 2 divided by 3 by root 9, which gives us minus 2 divided by 3 by 3. So 3 by 3 gets cancelled and is equal to 1. So finally you get t equal to minus 2. Now remember that the test is a two-tailed test. So the condition for a two-tailed test under small sample test is you have to check whether modulus of t is greater than t alpha by 2. If it is greater than t alpha by 2, then you reject H naught, otherwise you accept H naught at alpha level of significance for n minus 1 degrees of freedom. Now that we have calculated t as minus 2, the next step is to calculate modulus of t, which is modulus of minus 2. Therefore, we get modulus of t is equal to 2 because the modulus of any negative number becomes positive. Next, find out the degrees of freedom, which is n minus 1, which is equal to 10 minus 1 equal to 9. So at 5% level of significance for 9 degrees of freedom from the statistical table for t-tests, we can get the value of t alpha by 2 as 2.26, and this value is obtained under the two-tailed column, okay, for 5% level of significance for 9 degrees of freedom. Last step is the conclusion. Since mod t is equal to 2 is not greater than t alpha by 2, which is equal to 2.26 at 5% level of significance for 9 degrees of freedom, we accept H naught and conclude that mu is equal to 30. Problem 2. 10 individuals are chosen at random from a population. Their heights in inches are 63, 63, 66, 67, 68, 69, 70, 70, 71, and 71. Can we conclude that the mean height of the population is 66 inches? Now, in this problem, the word mean is used, and we see that a random sample of 10 persons is chosen. Now, n is equal to 10, which means that it is less than 30, and this problem is based on t-test for single mean. So from the problem, a set of data is given and we have to find the other two values, that is n and mu naught. So under solution, write given n is equal to 10 and mu naught is equal to 66, alpha is equal to 5%. Now we also will be needing the value of the sample standard deviation, that is S, and we need the value of x bar, which should be computed from the given data. Let us write H naught. The population mean is 66, that is mu is equal to 66 versus H1. Mu is not equal to 66. So this is a two-tailed test since the words like greater, less than, above, below are not used. So under H naught, the test statistic is t equal to x bar minus mu naught divided by s by root n minus 1, which follows t n minus 1. X bar is calculated using the formula summation x by n, and s square, that is the sample variance, is calculated using the formula summation x minus x bar whole square divided by n. Let us now form a table with the first column as x with the values given in the problem. X values are 63, which is repeated twice, 66, 67, 68, 69, 70 is repeated twice, and 71 is repeated twice. Let us now find out summation x, which is equal to 678. The next step is to calculate x bar. So consider x bar equal to summation x by n. The data given is raw data. That's why the formula is summation x by n, that is equal to 678 divided by 10. We get x bar as 67.8. The next step is to calculate x minus x bar the whole square. So take the first value 63 and then subtract it from the mean, which we have just now got, that is 67.8, and this is equal to minus 4.8. Minus 4.8, you square it and you get 23.04. So in a similar way, take each x value subtracted from 67.8 and square it. So the remaining x minus x bar, the whole square values are 23.04, 3.24, 0.64, 0.04, 1.44, 4.84 is repeated twice, and 10.24 is repeated twice. The next step is to calculate summation x minus x bar the whole square, which is 81.6. Let us now calculate the sample variance, which has the formula small s square is equal to summation x minus x bar whole square by n, which is equal to 81.6 divided by 10, which implies s square is equal to 8.16. Our aim is to find out s, which we require for the test statistic, so which implies s is equal to root of 8.16, and you get s as 2.8566. Substituting all the terms in the test statistic, we get t equal to 67.8 minus 66 divided by 2.8566 whole divided by root of 10 minus 1. So which is equal to 1.8 divided by 2.8566, and we know that a root of 9 is 3, so it is divided by 3, which is equal to 1.8 whole divided by 0.9522. So T is equal to 1.8904. The condition which we use to reject H naught for a two-tailed test is You have to check if mod t is greater than t alpha by 2. So find out modulus of t. So it is modulus of 1.8904. The modulus of a positive number remains as positive. Therefore, mod t is 1.8904. The degrees of freedom are n minus 1, which is equal to 10 minus 1 equal to 9. So at 5% level of significance for 9 degrees of freedom from the statistical table for the t-test, look under two-tailed test at 5% for 9 degrees of freedom. You get T alpha by 2 value as 2.26. Next, let us write the conclusion. Since mod T is equal to 1.8904 is not greater than 2.26 at 5% level of significance for 9 degrees of freedom, we accept H naught and conclude that mu is equal to 50. Problem 3. The mean weekly sales of ice cream bars was 146.3. After an advertising campaign, the mean sales in 22 stores for a typical week increased to 153.7 and showed a standard deviation of 17.2. Does this evidence indicate that the advertisement was successful? In this problem, the words mean and standard deviation are used, and if we observe the sample size is 22 stores, that means n is equal to 22, which is less than 30. So the given problem falls in the category of t-test for single mean, and hence we should be able to get four values from the problem, that is n, x bar, mu naught, then either s or s square. So under solution, let us list down the values which are given. So you have mu naught is equal to 146.3, n is equal to 22, then the sample mean x bar is 153.7 and the sample standard deviation s is 17.2, alpha is 5%. The next step is to write H naught. So H naught is the population mean is 146.3, that is mu is equal to 146.3 versus H1 mu is greater than 146.3. This test is a right-tailed test because of the word increased to. Or they have also asked in the last part of the question, does this evidence indicate that the advertisement was successful? So they are asking us whether the sales for a typical week has increased. So because of the word increase, the alternative hypothesis is a right-tailed alternative. Under H naught, the test statistic is t equal to x bar minus mu naught divided by s by root n minus 1, which follows t n minus 1. Hence, t is equal to 153.7 minus 146.3 divided by 17.2 whole divided by 22 minus 1, which is equal to 7.4 divided by 17.2 by root 21, which is equal to 7.4 divided by 17.2 divided by 3.7533, which is equal to 7.4 divided by 4.5826, and we get the value of t as 1.9716. Now remember that this test is a right tail test. So the condition which is used is you have to check if t is greater than t alpha at alpha level of significance for n minus 1 degrees of freedom, then you reject H naught. Here the degrees of freedom is n minus 1, which is equal to 22 minus 1, which is equal to 21. So at 5% level of significance for 21 degrees of freedom in the statistical tables for the t-test, look under one-tailed test 5% level of significance. So the conclusion, since t is equal to 1.9716 is greater than t alpha equal to 1.72 at 5% level of significance for 21 degrees of freedom, we reject H naught and conclude that mu is greater than 146.3. Problem 4. 10 students are selected at random from a school and their heights in centimeters are found to be 100, 104, 110, 118, 120, 122, 124, 126, 128 and 130 centimeters. Test at 5% level of significance that the average height of all the students in the school is greater than 110 centimeters. In this problem, the word average is used and we see that the random sample size is 10, which is less than 30. So this test falls in the category of t-test for single mean. Now we should be able to get two values, that is n and mu naught. So under solution, write given mu naught is equal to 110, which is the mean of the population, and n is equal to 10 and alpha is equal to 1%. The next step is to write h naught and h1. So h naught is the population mean is 110, that is mu is equal to 110 versus h1 mu is greater than 110, because in the question they have asked us to check whether the average height of all the students in the school is greater than 110. So because of the word greater than, the alternative is a right-tailed alternative. Under H naught, the test statistic is T is equal to x bar minus mu naught divided by S by root n minus 1, which follows T n minus 1. Since the values of x bar and S are not given to us in the problem directly, we have to use the data which is given and then calculate x bar and S square. So x bar formula is summation x by n and S square is summation x minus x bar the whole square. Now form a table and write down the x values from the given problem. The values are 100, 104, 110, 118, 120, 122, 124, 126, 128 and 130. Next calculate summation x, which is equal to 1182. Now we need to find out the mean of the sample, which has the formula x bar equal to summation x by n, which is equal to 1182 divided by 10. So you get x bar equal to 118.2. Column is x minus x bar whole square. So take the first x value 100, subtract it from 118.2, which is equal to minus 18.2, and then when you square minus 18.2 you get 331.24. In a similar way, take every x value in the first column, subtract it from the mean which is 118.2 and square it. So the remaining x minus x bar whole square values are 201.64, 67.24, 0.04, 3.24, 14.44, 33.64, 60.84, 96.04, 139.24, and we get summation x minus x bar whole square is 947.6. Now we need to calculate the sample variance, which has the formula small s square equal to summation x minus x bar whole square by n, which is equal to 947.6 divided by 10. So s square is equal to 94.76, or s is equal to root of 94.76, that is s is 9.7345. So we get t equal to 118.2 minus 110 divided by 9.7345 by root of 10 minus 1, which is equal to 8.2 divided by 9.7345 divided by root 9, which gives us 8.2 divided by 9.7345 divided by 3, that is equal to 8.2 divided by 3.2448. Therefore, T is equal to 2.5271. Now, the condition which we should use for a right tail test is you have to check if T is greater than T alpha. So, let us find out the degrees of freedom, that is n minus 1, which is equal to 10 minus 1 equal to 9. Now, at 1% level of significance for 9 degrees of freedom, we get the value of T alpha as 2.82 from the statistical table for the T test. Under T test, you have to look for single tail test at 1% level of significance. Conclusion: since T is equal to 2.5271 is not greater than T alpha, which is equal to 2.82 at 1% level of significance for 9 degrees of freedom, we accept H naught and conclude that mu is equal to 110. Problem 5. A company states that it sells on an average 5,600 articles in a month, but the inspector feels that it is less than 5,600. He randomly selects 17 months and finds that on an average the sales is 5,750 with standard deviation 175. Conduct the test at 1% level of significance. So, in this problem, the word average and standard deviation is used, and they have mentioned that he randomly selects 17 months. That means n is equal to 17, which is less than 30. So, the problem is based under t test for single mean. Hence, we need to get four values from the problem, that is n, x bar, mu naught, then either s square or s. So under solution, write given mu naught is 5600, n is 17, x bar is equal to 5750, s is 175 and alpha is 1%. Next, let us write h naught. The population mean is 5600, that is mu is equal to 5600 versus h1 mu is less than 5600. Now, in the question, they have mentioned that the inspector feels that the sales is less than 5600. So, because of the word less than, the alternative will be a left tailed alternative. So, you have H1 mu is less than 5600. Under H naught, the test statistic is T equal to x bar minus mu naught divided by S by root n minus 1, which follows T n minus 1. Substituting in a test statistic, we get t equal to 5750 minus 5600 divided by 175 divided by root of 17 minus 1, which is equal to 150 divided by 175 by root 16, which is equal to 150 divided by 175 by 4, which is equal to 150 divided by 43.75. Hence, t is equal to 3.4286. The condition to be used for a left-tailed test is you have to check if t is less than minus t alpha at alpha level of significance for n minus 1 degrees of freedom, in which case you reject h naught, otherwise you accept h naught. So the degrees of freedom is n minus 1, which is 17 minus 1 equal to 16. At 1% level of significance for 16 degrees of freedom, we have minus T alpha is equal to minus 2.58. So the value 2.58 can be obtained from the statistical table for the T test under single tailed test, and we prefix the negative sign. So we get minus T alpha as minus 2.58. Conclusion: since T is equal to 3.4286 is not less than minus T alpha equal to minus 2.58 at 1% level of significance for 16 degrees of freedom, we accept H naught and conclude that mu is 5600. Problem 6. It is required to know whether those who practice yoga have average blood sugar less than 120. A sample consisting of 18 persons who practice yoga is observed. If their mean blood sugar is 108 and standard deviation is 8, what would you conclude? Now, in this problem, we see the words average and standard deviation, and the sample consists of 18 persons. So, 18 is less than 30, and this test is based on t test for single mean. So the four values which can be obtained from the given data are written under the solution. So given mu naught is 120, n is 18, x bar is 108, s is 8, and alpha is 5%. H naught will be the population mean is 120, that is mu is equal to 120 versus H1 mu is less than 120. The alternative hypothesis is a left-tailed alternative because in the question they have asked us to check whether those who practice yoga have average blood sugar less than 120. So because of the word less than, the alternative is a left-tailed alternative. Under H naught, the test statistic is T equal to x bar minus mu naught divided by S by root n minus 1, which follows T n minus 1. On substitution of the values in the test statistic, we get T equal to 108 minus 120 divided by 8 by root 18 minus 1, which is equal to minus 12 divided by 8 by root 17, which is equal to minus 12 divided by 8 by 4.1231, which gives minus 12 by 1.9403. Therefore, T is equal to minus 6.1846. Degrees of freedom is n minus 1, which is equal to 18 minus 1, which is equal to 17. The condition which is used for this left tail test is T is less than minus T alpha. If this condition is satisfied for n minus 1 degrees of freedom at 5% level of significance, then we'll reject H naught. So at 5% level of significance for 17 degrees of freedom, we get minus T alpha is equal to minus 1.74. So 1.74 is obtained from the statistical table under T test and then look under single tailed test. Then 1.74 is prefixed with the negative sign because we are testing for a left tailed alternative. So the conclusion, since T is equal to minus 6.1846 is less than minus T alpha equal to minus 1.74 at 1% level of significance for 16 degrees of freedom, we reject H naught and conclude that mu is less than 120. The problems on t-test for single mean are important 5 markers. Do practice the problems thoroughly and understand the concepts well. Thank you all for watching and look out for my next video where I'll explain the procedure for test for equality of means for small samples.